Welcome to the Explainer. I am absolutely thrilled you're here. We are jumping right into things today and transforming this space into a hands-on, interactive Python workshop. Think of me as your friendly coding coach, just sitting right next to you. Whether you're entirely new to programming or just looking to solidify your foundation, we're going to master exactly how Python stores and manipulates data. And we're doing it the best way possible, by looking at real code, writing real code, and seeing real results. So let's get started. Here's our roadmap for today's Explainer. We're following a sort of see it, do it, review it interactive method. First up, setting up your environment. Second, variables and dynamic typing. Third, exploring core data types. Fourth, practice challenges, and yep, that means it's your turn to code. Finally, we'll do a live solution walkthrough. If you haven't already, go ahead and open up your preferred code editor like VS Code or Google Colab because coding is a contact sport, and you are definitely going to need it very soon. Okay, let's dive into this. Part 1. Setting up your environment. Before we can write the next great piece of software, we need a place to actually write it. Setting up your workspace is incredibly straightforward. Step 1, you literally just create a new file in your editor. If you're in VS Code, name it something like main.py. Or if you're using a Jupyter environment like Google Colab, you'll be working in a .ipynb notebook. Step 2 is writing our very first instruction, a simple print statement, which basically just tells Python to display something. And step 3, honestly the most satisfying part, executing the code. This is where you actually tell the computer to follow your instructions and breathe life into your text. You just click the play button in your editor or hit Shift+Enter. Let's actually see this in action. We type print, open our parentheses, open our quotes, and write hello world. When we hit run, focus your attention right down on the terminal or console window at the bottom of your editor. Boom. You should see hello world pop right out. There is really nothing quite like the satisfaction of that first successful output. The terminal is exactly how Python talks back to you. It's your direct line of communication. You have officially just commanded your computer using Python. Moving right along to part 2, variables and dynamic typing. Now that our environment is up and running, we really need to understand how we actually store and remember information within our programs. At the heart of absolutely all programming is the concept of a variable. I want you to visualize a variable simply as a digital container or maybe a sticky note label. Your computer has massive amounts of memory, right? When you want the computer to remember a specific piece of information, like a user's name or a high score, you put that data into a container and you stick a label on it. And hopefully you're using a better, more descriptive label than just box 1. That label is your variable. Whenever you need that data again later, you just call out the label's name and the computer instantly fetches the contents for you. And this brilliantly illustrates how we actually write these labels. Python has some strict but pretty simple rules. We use a convention called snake case for valid names. Notice user_age and first_name. They're all lowercase, with an underscore acting as the space. Looking at the invalid side, you cannot start a variable name with a number, so first_user will literally break your code entirely. And you definitely cannot use actual spaces, so first name with a space is a total no-go. Why? Well, because the computer reads a space and assumes it's looking at 2 completely separate commands, which immediately triggers a syntax error. Just stick to snake case and your editor will be very happy. Imagine we're in our editor right now. I'm going to type user_=100. Now, the equal sign here is not asking a math question. It's what we call the assignment operator. We're taking the data value of 100 and putting it directly inside our newly created user_ container. On the next line, we type print, open parentheses, user_. Notice we don't use quote marks here. If we use quotes, it would just print the literal word user_. We want the contents of the variable, right? So, no quotes. When we hit run, our terminal outputs 100. Perfect. Let's head into part 3, exploring core data types. We're going to see how our containers can hold many different flavors of data. Our data comes in 4 foundational building blocks. First up, we have integers, using the keyword int, which are your basic whole numbers like 42 or -10. Then we have floats, using the keyword float, which handle decimal numbers like 3.14. Third, we have strings, keyword str, which are basically just text characters wrapped in quotes like the word Python. And finally, booleans, keyword bool, which represent binary truth, so either true or false. Understanding what type of data you're currently holding is absolutely crucial. Because, well, Python will happily let you do math with integers, but it will throw an absolute fit if you try to say divide a string. For instance, look at how we work with strings. In our editor, let's assign the text hello to the variable greeting and the text dev to the variable name. If we want to stitch these together dynamically, we can actually use the plus sign. Inside our print statement, we type greeting plus an empty space in quotes plus name. You might be wondering why I added that empty space in the middle. Well, because computers take us completely literally. Without it, our terminal would read hello dev, all squished together into one word. When we run this with the space included, the terminal perfectly reads hello dev. This is called string concatenation, and it's exactly how we build dynamic text. But things can get kind of tricky when we mix types. Python treats the number 5 very differently depending on if it's an integer or a string. If you ever need to change a data type on the fly, you use something called typecasting. Using string of 5 is basically like leaning over to Python and whispering, hey, take this mathematical number 5 and just turn it into text. Conversely, into 5 tells Python in a very serious tone, take this text character 5 and convert it into a mathematical integer I can actually do math with. You are explicitly commanding the computer to translate the data. Now, if you ever get lost in a complex program and you completely forget what type of data is hiding inside your variable container, Python actually provides a built-in rescue tool, the type function. Seriously, it is a developer's absolute best friend. If we type print type 3.14 and hit run, look at what the terminal spits back to us. Class float. The computer explicitly tells us exactly what we're dealing with. You're going to use this tool constantly when debugging your code to make sure your variables are holding exactly what you think they're holding. All right, part 4, your turn. Practice challenges. We've covered the lesson, and now it's the moment of truth. Time for you to take the wheel. I've got 3 practice challenges for you to execute in your IDE right now. Challenge 1, create 3 correctly named variables for a product name as a string, a price as a float, and a quantity as an integer. Then print them out. Challenge 2, try to print a statement that adds the word total to the number 5, and then fix the error that inevitably pops up. Challenge 3, use that type function we just talked about to check the type of your product variable from the first challenge. And hey, don't worry for a second if you get an error. That is quite literally just part of being a developer. The best way to learn is by breaking things and fixing them. I want you to physically pause this explainer right now, write the code, run it, and see that terminal output. Go ahead, I'll be right here when you're done. Welcome back. Part 5, Live Solution Walkthrough. I really hope you enjoyed getting your hands dirty in the editor. Let's walk through these solutions step by step and see how your code actually compares. For challenge 1, let's build a really clean, simple solution. We create product and assign it the string coffee. We create price and assign it the float $4.99. And we create QTY and assign it the integer 2. To print a summary, we can just pass them all right into the print function separated by commas. Looking at our terminal output, it cleanly reads coffee $4.99 too. Notice how seamlessly Python prints completely different data types when they're separated by commas like that? It actually handles all the spacing automatically for us. Now for challenge 2, the intentional gotcha. If you try to just write print total plus 5, your terminal likely screamed at you with some angry red text type error. Honestly, don't panic. This is incredibly common. Python is just confused. It's looking at the code and basically asking, wait, do you want me to do mathematical addition, or do you want me to stitch text together? You can't ask me to add an integer to a string directly. That just doesn't make logical sense. So the crucial point here is that we must use typecasting to translate our data so Python understands our intent. We just wrap our integer 5 inside the str function. By writing print total plus str5, we turn the mathematical number 5 into text first. Now Python is perfectly happy to stitch those 2 identical pieces of text together. When we hit run, the red error is totally gone, and our terminal outputs a beautiful, triumphant total 5. And finally, let's verify our data in challenge 3. If we write print type of product and run the script, our terminal confirms that our product variable is indeed holding data of the class string, a string. Using this function is exactly how professional developers ensure data is behaving exactly as expected behind the scenes. It just completely removes all the guesswork from your programming. Seriously, look at what you've accomplished today. You've set up a professional coding environment, you've commanded the terminal, you've built variables, you've manipulated different data types, and you even debugged a real syntax error. These are the foundational building blocks of absolutely everything in software development. Every single app on your phone, every website you visit, uses these exact principles under the hood. So now that you have the power to store and manipulate data dynamically, the big question is, what real-world problem are you going to code a solution for first? Thanks so much for joining me on The Explainer. Keep practicing in that editor, and I will see you in the next one.